1,4-butanediol is an important commodity chemical used to manufacture over 2.5 million tons of valuable polymers annually. Conventionally, it is synthesized by reacting acetylene with formaldehyde, or, to give their proper chemical names, ethyne and methanol. This produces 1,4-butanediol. 1,4-butanediol then undergoes hydrogenation to produce 1,4-butanediol. However, a bioprocess can be used to manufacture 1,4-butanediol too, one which only involves the use of simple carbohydrate, usually a simple sugar like glucose or fructose, and E. coli. This process is significantly cheaper, as common commodities like sugar and common bacteria are much more cheaper. A bioprocess is also significantly safer than a chemical process, not using hazardous chemicals such as methanol and ethyne. It would also use less energy than a standard process, not needing high temperatures or high pressures to complete the reaction, as the enzymes are specific and efficient. For these reasons, a bioprocess would seem to be a healthy alternative to a standard chemical process. The production of 1,4-butanediol first involves the production of an intermediate known as 4-hydroxybutyrate. The route to 4-hydroxybutyrate starts from first converting sugars into the butanedioic acid through the fermentation of sugars. The catalyst, succinyl CoA synthetase, native to E. coli, converts succinate into succinyl CoA. This is then reduced by enzyme CoA-dependent succinase semialdehyde dehydrogenase to succinyl semialdehyde. This is then reduced by 4-hydroxybutyrate dehydrogenase, and 4-hydroxybutyrate is formed. This is then converted to 4-hydroxybutyryl CoA, which is then reduced to 4-hydroxybutyrate aldehyde with the use of aldehyde dehydrogenase. This is then converted to 1,4-butanediol with the use of an alcohol dehydrogenase. The main biocatalyst present in the bioprocess is E. coli, with enzymes succinyl CoA synthetase, CoA-dependent succinase semialdehyde dehydrogenase, 4-hydroxybutyrate dehydrogenase, 4-hydroxybutyryl CoA transferase, 4-hydroxybutyryl CoA reductase, alcohol dehydrogenase also present. E. coli is a very common bacteria that is commonly found in the intestines of warm-blooded organisms. Most strains are completely harmless, although some can cause serious food poisoning. It is widely available from many pharmaceutical companies and from animals' intestines themselves. The other enzymes can be grown in a fermenter. E. coli is the main biocatalyst, as it supplies the enzymes for the first and last steps of the process. It does this by offering new biochemical pathways for the reaction to proceed, and enhancing anaerobic operation of the oxidative tricarboxylic acid cycle, which is oxidation of simple sugars, thereby reducing necessary power to drive the 1,4-butanediol pathway. One of the main issues with using a bioprocess is that the yield of the product is lower, as there are many intermediate reactions which are harder to control without the use of chemicals. The yield given in this case is around 37 weight-weight percentage. Another issue is the rate of reaction, which will be considerably slower, as in bioprocessing lower temperatures and pressures are used. As the reaction is started from sugars, the resulting mixture will be a sludge of liquids and solids. This will have to be separated in a centrifuge, and the resulting liquid will have to be purified via distillation to acquire 1,4-butanediol. The unwanted distillate would contain many alcohols and 4-hydroxybutyrate, which, if not handled properly, could be environmentally hazardous. Therefore, this distillate should be distilled again with 4-hydroxybutyrate being put back into the reaction, and the alcohol sold. This process is also very safe, not using flammable chemicals like ethyne, or dangerous irritants and known carcinogens like methanol, and only using bacteria, which, if properly controlled, should not be harmful in any way.